Hey everyone, welcome to today's lesson on the influences of weather. Today is November 20th, 2020. This is Mr. Richmond speaking. And yes, in the last lesson we talked about air masses and fronts and their interactions and how they play a role in our weather. And today we're going to talk about some other things that influence our weather, such as high pressure systems and low pressure systems. So we're going to explain those different systems and how they interact to produce different types of weather. So we're going to dive right in and see what will learn from it today. After this lesson, I'm hoping that you'll be able to compare and contrast a high pressure system to a low pressure system. And I'm also hoping that you'll be able to explain how high pressure and low pressure systems interact. So the interactions have a big role in how our weather is produced across the United States and across the world. So we're going to compare and contrast the two different types of systems and explain their interactions. And you can also see in this little graphic here, the warm front and the cold front that we talked about in the last lesson, they have a lot to do with low pressure systems, which is why this says low here. So as we go through this lesson, I'm going to show you how low pressure systems play a role in the development of warm fronts and cold fronts. So here we go. Alright, so we're going to start off by talking about what a high pressure system is. A high pressure system is an area of air pressure in which air sinks and gets warmer. And why is that? So at the top of the atmosphere, you have cool air, some very cool air, based on this little graphic here. At higher altitudes, air is cooler, and as it gets cooler, it begins to sink because it's more dense. Because it starts to get more dense as it gets cooler, and it sinks down to the surface. And as it sinks down to the surface, it begins to get warmer because the Earth's surface is a lot warmer than higher altitudes. That's why you have air. Cold air flowing from the top to the bottom and then starting to warm up in a high pressure system. And as you can see, it spirals in from the top, comes to the bottom, and then starts to spread out towards other regions of lower pressure. And so it spreads out in all directions, and some areas of low pressure will take this air as it warms and it'll go back up into the atmosphere, which we'll talk about in a little bit with low pressure systems. And if a high pressure system manages to stay in one place for a longer period of time, it forms an air mass. And remember, when we discussed air masses, we said that air masses are a region of air that sits in one place for a long time, such that it takes the temperature and moisture content of that area of the atmosphere, and it's the same throughout the air mass as it moves. So air masses typically form from high pressure, and from this scenario, we can get different types of air masses in the atmosphere. So that's what a high pressure system is. But now we're going to talk about how it influences weather. So high pressure and weather, air is sinking from the higher levels of the atmosphere, which means if the air is sinking, the air must be more dense than the air beneath it. So you have air sinking down through the high pressure system and then spreading out or splitting off, diverging winds out of the center of high pressure throughout the entire air mass that's formed here. The air in the high pressure sinks and warms, which allows it to absorb moisture and carry it towards low pressure. So as it sinks and it starts to get warmer, it begins to absorb a lot more moisture as it warms along the surface, which also will decrease the relative humidity as that air collects the moisture and spreads it out towards low pressure systems. So that's why you get a decrease in relative humidity along with cooler temperatures with a high pressure system typically. You may have some warm temperatures on the backside of high pressure systems, but that has to do with how high pressure and low pressure interacts, which we'll talk about in a minute. So high pressure usually brings clear skies and calm weather because the cool air does not have the moisture in the center of high pressure, where you would typically see it doesn't have the moisture to support thunderstorms or rain in any case as it sinks, because it's very dry air, it's very dense air, therefore it can't hold much moisture, and as it spreads out, it'll collect more moisture and carry it into low pressure systems. So high pressure usually will bring pleasant weather to an area. Alright, so now we're going to talk about a low pressure system. A low pressure system is a system of air pressure in which air rises and gets cooler. So it's kind of the opposite of a high pressure system. In a high pressure system, the air sinks and spreads out, but in a low pressure system, the air comes together towards the center of low pressure and begins to rise. So there's kind of a difference here, and we're going to talk about why that difference makes such a big influence on the weather that we see. All right, so low pressure and weather. So in a low pressure system, warm, moist air from the surface rises and cools in low pressure. Remember, this is most likely coming from higher pressure that has brought cooler air down to the surface and is pulling it towards the low pressure system. And as it warms and collects moisture, as we mentioned, what happens in high pressure air masses, it goes to the center of low pressure and begins to rise, or areas in the low pressure system, and it begins to rise. And as it rises, remember, air begins to cool as it rises. And as it cools, remember, it can't hold as much moisture once the air cools because of the density of the air. So that's why you get clouds like different clouds forming rain in the center of low pressure quite often. And fronts also follow this same type of pattern where warm air rises and then behind it is cooler air. So that's how this low pressure system works. And yes, low pressure systems typically produce rainy weather based on this scenario that we have put out in this model. So what really changes our weather is the interaction of high and low pressure. There's a lot of different things that come together when we discuss where low pressure is in relationship to high pressure and what that means for our weather. So air spirals between high pressure and low pressure systems. Remember, you guys talked about this in your gizmo, or you worked on it with your gizmo, and we discussed how high air in high pressure moves clockwise, and then how lower pressure the air moves counterclockwise. So you have a counterclockwise motion of air with a low pressure system and a clockwise motion with high pressure system. And what that means is, pay attention to the back side of this low pressure system and the front side of this high pressure system. Notice how the arrows on the back side of this system and the front side of this system are pointing down. That allows cool air from the north, at least in the United States, cool air from the north to be pulled down towards the south, which is why typically after you see a strong thunderstorm move through in the fall, like we saw on Sunday of this week, we saw strong thunderstorms move through and then followed by very strong winds and much cooler air the next day. That's because this low pressure system pulled the cool air down into our area and pulled it down fast because of strong winds. But on the flip side of that, if you go to the back side of high pressure and the front side of lower pressure, notice how both arrows in the circulating motion of these pressure systems are pointing up on these sides. That allows for warm air from the south to be pulled up to the north. So that influences our weather in that when we're on the back side of high pressure, we will more likely see warm air, and that warm air, if it's moist, will allow low pressure systems the ample moisture they need to produce rain. So the interactions between these different types of pressure systems are extremely important in how we forecast weather. So pressure systems are something we pay very much attention to. And as I identified here, warm air typically sits ahead of low pressure. The warm air will typically sit ahead of low pressure, and cool air will typically sit behind low pressure. So behind low pressure here, we have the cool air coming down, and then in front of the low pressure system here, we have the warm air going up. So to help you visualize this, I'm going to show it to you on an actual weather map. All right, so here we have a weather map for today is Wednesday. So, well, I recorded this on Wednesday. So this is a weather map for Wednesday. You can see that we do have a high pressure system here, and it's actually over our region on Wednesday. So that makes it very nice weather for Wednesday, which it has been very nice. It's been very cold, but it has been very nice weather. It was very nice weather on Wednesday, if you remember back to there. And back up here in Canada, we have a low pressure system, and you can see that there's some moisture or some snow falling up here in the colder areas of the low pressure system, or the northern side. And then you have on the back side of it, you have a bunch of moisture being pulled down. So remember, in high pressure systems, the air is typically in a clockwise motion. So I want you to pay attention to how the different lines on the weather map are changing as you move in a clockwise motion. The high pressure system. I'm going to zoom in a little bit to help you see. But the blue lines here represent colder air. So in a clockwise motion, you can see that the warmer air from the high pressure is being pulled way up into the beginnings of Canada and Minnesota, or the northern part of the United States. And as it wraps around, it begins to pull cool air down into the New England states, or Pennsylvania, New York. And you can see that this is kind of tight. These little isobars are really tight, indicating that there's a lot of wind being pulled up, which means it'll likely get very warm up in this region coming soon on later into the week, which today is Friday, and Friday was forecasted to be 62 degrees. So 62 degrees is quite a bit warmer than the 42 that we were seeing on Wednesday. So low pressure system, on the other hand, remember the air moves in a counterclockwise motion, so it's moving this way. And you can see how warm air is being lifted up a little bit higher than the cooler air back here as it moves in a counterclockwise motion. So as you pull it down, you can see the cooler air is being pulled down south, and the warm air is being pulled up by the low pressure system. And the low pressure system, remember, takes in the warm air and the moisture, and it condenses in the low pressure system to produce the rainfall that we see around it, or the snowfall, based on where moisture is taken to. So we have snowfall up here, snowfall back here, influenced by this low pressure system, whereas this high pressure system is taking this cool air that is up here in the atmosphere and pulling it down to the surface of the United States around here and allowing the air to warm. So seeing it on an actual weather map may help you determine how weather is changing across the country. So let's go back to the PowerPoint now. Fix this real quick, as I always must. All right, so hopefully that was a good description of the interactions between high pressure and low pressure. I want to show you this graphic because it puts both of the pictures of high pressure and low pressure together. So high pressure, remember, you have the air sinking down, the cool air from the upper levels of the atmosphere sinking down to the surface and beginning to warm up. So the high pressure system brings the air down, and now as it's on the surface, the solar energy allows it to warm up. And then as you move to the other side, behind it, there's a low pressure system. And notice how as these arrows travel down in the high pressure system, the air in the low pressure system seems to just take that high air from the high pressure up. So it takes that warm air as it warms, as it crosses into the low pressure system, it takes it up. And on the flip side of that, literally, you have the low pressure system that's taking that air from the high pressure system back up here, and it's pulling this air up, and it's also pulling the air from the high pressure system behind it up, which is warmer air that allows the low pressure system to condense and produce rain up here. And then as this air goes up into the upper levels of the atmosphere, you have high pressure taking it down after it's cooled down into the surface, where it warms again. So the cycle can be kind of seen pretty well of low pressure and high pressure. Low pressure takes less dense air up, high pressure takes more dense air down. So that's another image of the interaction between the two. And then here's another image of how high pressure and low pressure tends to travel. You can see the counterclockwise motion of low pressure and the isobars that indicate where the pressure is in the atmosphere. So this low pressure system is 984 millibars, which is what we use to measure low pressure. Whereas as you get to high pressure off to the west, you can see that the pressure begins to rise with the isobars. So 1,000, 1,004, 1,008, 1,012, and then you have the high pressure here. So the high pressure is in a clockwise motion here. The movement of the wind and the air in the atmosphere is clockwise, and it's sinking from this high pressure system, which is why you have the pressure reading you have here, and it begins to warm before it gets into the low pressure system. All right, so this was a little bit short, but there's some things you're going to have to do in order to in order for me to be able to understand that you got what was in this video. So we compared and contrasted high pressure systems to low pressure systems in this video, and now we can explain how high pressure and low pressure systems interact, which is what I was hoping you guys would get, with also an activity that I'm going to have you guys do after this lesson or this video. So what I want you to do is, there's a weather map of the United States that shows high pressure and low pressure in the atmosphere, or the forecast for today. I made it available on Google Classroom. So what I want you to do is download this map and open it in a drawing application. So on Chromebook, there should be a drawing application of some type. And what I want you to do is to open up the image that you download from Google Classroom that Mr. Williams and I put there. And I want you to open it up such that you can draw on it. And if you can't draw on it and you have a printer at your house, you could also just print it and then draw on it using a pen or a pencil or something like that. So what I want you to draw is to draw arrows on the map indicating the movement of air based on the high pressure and the low pressure systems. So what I want you to do is kind of like this. I just want you to draw these arrows just like indicating where the air in the atmosphere is moving. So find each high pressure and low pressure system and just draw the arrows representing where it's moving. But that's not it. I want you to try and use colors with your arrows to indicate where cold air is flowing and where warm air is flowing. So remember, we talked about we'll go back. Remember, we talked about how warm air flows in front of low pressure systems and behind high pressure systems, and how cool air typically sits behind low pressure. So what I want you to draw colored arrows, red arrows representing warm air flowing between pressure systems, and blue representing cold air flowing between pressure systems. And if you're not entirely sure, just draw an arrow in regular black ink and see if that will be okay too. But I want you to try and draw red for warm air and blue for cold air. So try and draw arrows for that. I'll show you an example. So this is a weather map I drew. This was for Monday, this coming Monday, a forecast for this coming Monday. But so I saw a low pressure system up here near Canada, Hudson Bay. I'm marking it with my laser pointer. So I indicated that there's probably cold air being sucked down from this low pressure system into Ohio, which is why we're seeing cooler temperatures on Monday, most likely. And the high pressure, I actually just drew arrows indicating the clockwise motion of the high pressure system. If you could do that for the high pressure systems, that would be good too. So just indicate, okay, is it going clockwise or counterclockwise? Identify that for me. Also, you have a low pressure system down here in Mexico. So I just drew a red arrow and a blue arrow indicating where that is, which way the wind is moving in that low pressure system, and whether it's warm air or cold air. And I did it for this low pressure system too. I indicated, okay, there's red for warm air. Warm air is being pulled from the Pacific Ocean and going around, and the cool air from Canada is coming down into Mexico. So if you'd like to do this by hand, you can put the weather map at home or draw the arrows in a weather map. But just try and look at the weather map and take your best shot at identifying the different wind patterns in the atmosphere, and that'll be submitted as your exit slip for this class. And there will also be some other videos provided for you in Google Classroom for more information. So I gave you a video in Google Classroom about weather and pressure. Go ahead and take a look at that. And I also provided to you a video on hurricanes that explains how high pressure and low pressure interact to produce hurricanes, and also gives you some more information about hurricanes. So you can take a look at those if you're interested. Hopefully this lesson was helpful to you in understanding interactions of high pressure and low pressure. And thank you for watching it. And I hope to see your work through the exit slip soon.